Hey, this is Mr. Warden. I'm going to walk through how to deal with the Quadratics 3 price optimization type problems. I'll also do one or two involving area in case you needed to come up with the right size fencing for your favorite yak herd. Okay, so we're going to start off with this situation. You have decided to sell pointy hats for $40. You've discovered that you can also sell them, you can sell 1,000 of them if you sell them at that price. But you also have done some market research. You learned that if you raise the price by $2, you'll lose 10 sales because it gets more expensive. People don't want to buy them as much. And every time you raise the price by $2, you'll lose 10 sales every single time. So, are you selling them for the right price? We can use quadratics to figure this out. So, if you remember, quadratics, one way to think of them, is a product of two linear equations. Now, so this is a situation that lends itself to a product. So let's start off with a basic product here. We're going to figure out the revenue. And the revenue equation, in this case, is simply revenue equals price times sales. And we know the price. The price is $40, and we are multiplying $40 times 1,000 sales. And so you're going to make $4,000. Sorry, what am I saying? $40,000. You're going to make $40,000 here. Okay, but how do we apply all of this extra information? So here's how we apply it. So you're going to be raising the price by $2. And if you raise the price by $2, you will lose 10 sales. And at that point, you've lost sales, but you're still making more money, which is kind of neat. Price times sales equals how much income you're making on this. But what if we wanted to find out for any number of price increases? So what we're going to do is we're going to declare a variable here. So I'm going to declare that, and here's the thing we don't know. We don't know how many steps of $2 price increases we want to make. Okay, so what we want to do is we want to come up with an equation for price in terms of the number of any number of steps and sales for any number of price hike steps. So I'm going to say X equals the number of times you raise the price by $2. So we can go ahead and plug that in. So it's going to be $40 plus $2 times X, because X is going to be the number of times you raise the price. But every time you raise that, it's also going to cause you to lose 10 sales. So that's going to be, this over here is the sales equation. 1,000 minus 10 sales lost for every single time you raise the price. So now we actually have a function, and I'm going to call this the function R for revenue, in terms of X equals, and just beware, I'm going to be using more function notation as we move in more into this polynomials unit. So here we have, and this is just a fancy way of saying Y, okay? And so we now have something we graphed. We've graphed. Well, where's the graph, Mr. Ward? Well, the graph is here. Well, there's parts of the graph, but can't really see much of it. I can see we've got an x-intercept at negative 20 and an x-intercept at 100. So that's negative 20 price hikes. So if you lower the price by $2 20 times, you will make zero money. That Y is the money. That's the revenue. This is how many price increases you've made. So you've made the opposite of price increases. You made 20 price decreases, which means you've done 20 times $2 going down. So you went from $40 to $0. So it makes some sense that you wouldn't make any money because you're selling the hats for nothing. So if you're selling the hats for nothing, it doesn't matter how many you're going to sell. Over here, you've made 100 price increases. So you've gone from $40 to $240 because you've raised the price by $2 100 times. That's raising the price by $200. Your price of your pointy hat is now $240. And at this point, you have zero revenue because you have zero sales. No one wants to buy it. But what is somewhere in between here is a point on this graph, and we can't see it yet. So what we're going to do is we're going to adjust this graph. I could just zoom out, but I'm going to adjust this graph to be something that we could see. So I'm going to first make it a little bolder, and I'm going to move my face out of the way. And what I want to do is I want to stretch out the x-axis a little bit. So I'm going to stretch that out to -40 and out to 140 over here. And then I'm going to squish the y-axis. I can squish the y-axis. So I'm going to start at, say, make it -1,000, because that'll be reasonable in this situation. And we'll go up to 60,000. I think I need to go up to 70,000. So I'm clearly a little off the graph. Let's see what happens at 70,000. Okay, I guess we need to go to 80,000. So I'm going from -1,000 on y up to +80,000 on y. So here we've got my graph, and here are some key points on this graph. We've got a y-intercept. Y-intercept is when I haven't raised the price at all, and I've got 40,000 income. Down here is an x-intercept when I've raised the price so much. Somewhere in there. Oh, it's down here. I'm sorry. Actually, I'm going to scroll up, move up a little bit. Here's my x-intercept where I have raised the price so many times that no one wants to buy my pointy hats, or you have, I should say. And here is what's called the vertex. This is the peak. This is the highest the y value or r of x can possibly be on this graph. It is after 40 price hikes, you will be making $72,000. So x is 40, and this is the most you'll be able to make. You will have lost customers. Each of those 40 times you raised the price, you lost 10 customers, which means you've lost 400 customers at this point from your original 1,000. But you're making more money because you have not lost enough customers to start losing money. All along here, you're raising the price, losing customers, raising the price, losing customers. You're going up, but slowing down. Eventually, you reach as high as it can go. After here, you're losing enough customers to lose money, to make less money. So it's useful to think a little bit about what these equations over here are. I'm going to stretch that out a little bit. This here is the price equation. So we've worked out that if x is 40, we know what our new price is going to be. So it's going to be 40 plus our starting price of 40 plus 2 times 40 price increases. So your new pointy hat price, your best hat price, is $120 based on your market research. Now let's see how many customers you'll have at that point. This is the sales equation. So we plop that in here. And once again, we can replace x with 40 because you've raised the price 40 times. Each time you lost 10 customers. And so you're now at 600 customers. But even though you've lost 400 customers, your new price is making you a lot of money. So 600 times 120 is going to get you this high revenue mark of $72,000. And so you're in the money, you're in the money. And so here, I'm just going to review the key points on here are your vertex, the highest or lowest point in a parabola. Since this is a frowny face one, it's the highest place, also known as a maximum, as opposed to a minimum if it was a happy one. So that's the maximum. This is before you raise the price at all. $40 times 1,000 gets you $40,000 of income from your hat sales. Down here, after 100 price increases, you have now driven all your customers away. So your x-intercept over here is you've driven all your customers away. There's another x-intercept over here in which you've lowered the price so much that now you're selling the hats for $0. So it doesn't matter how many customers you have. You're just going to not make any money. All right, and the equation that we set up, just to review, it started off with revenue equals price times sales. This is the price, $40, times the sales of 1,000. If we raise the price by $2, we lose 10 customers. But then we can adjust that a little bit into a function in terms of x. We make 2 times any number of price hikes, then we can call that 40 plus 2x. That's our price for any number of price increases. And then we change this 1,000 minus $10 to 1,000 sales minus 10 sales lost for that $2 increase to 1,000 sales minus 10 times any number of price hikes. And then we've got a sales equation or expression. So price expression times sales expression gets us our overall parabola, and that's graphed right here. And once again, 2 linear equations multiplied times each other got us a quadratic polynomial. Then we got that 40 was the x value at the very top, the vertex of this parabola. And so we could take our price equation, replace x with 40, and we could find out our maximum price for making the most money. That's what I should say is the optimal price. So our optimal price is $120. Down here, we also can find out how many sales. How's that price affecting our sales? So that price comes from 40 price increases. So 1,000 sales minus 10 sales lost for every $2 increase times 40 price increases is going to get us 600 sales. And there you have it. I hope that helped.